Okay, as we continue our wonderful adventure with exponents, I want to talk about how you multiply two things with exponents. For example, let's say I want to multiply x squared times x to the fifth. Well, what you do is I have two x's that are coming from the squared, and I have 5 more that are coming from this x to the fifth, and if you count those up, altogether you have x to the seventh. Now, you don't have to do this every time. The shortcut is, I think you'll see this if you do a few more problems, but the shortcut is that when you multiply, you add the exponent. So I have 3 x's here, and I have 7 more here, so altogether I am multiplying 10 of them. So even though we're doing multiplication, the exponents add. That's how you multiply when there are exponents involved. Be really careful, because here's one that I see a lot. People might have something like this, 2 to the third and 2 squared. Now, you are not going to take 2 times 2 and write 4 here. You leave the 2 the way it is, and you add the exponents. So 3 and 2, I have 5. And once again, the base did not change. Just like this x here didn't change into something else, the 2's here shouldn't change into something else. You multiply these by adding their exponents. Okay, related to multiplying exponents is what happens when you want to raise an exponent to a power. So let's say I have x squared, and instead of multiplying by x to the fifth, let's say I want to raise it to the fifth power. Well, you could write it all out, x squared times x squared times x squared times x squared times x squared. And you say, oh, I have 2, 4, 6, 8. I have 10 of them, so it's x to the 10th. But again, I think you see there's a shortcut here. And for this problem, the shortcut is that when you raise to a power, you multiply the exponents. Sometimes how I look at it is I say that exponents lag behind. Exponents are lazy, in a sense. Exponents are lazy. Because whatever operation you're trying to do, the exponents are always one step behind. So when you want to add, the exponents don't do anything. Like if I want to add 2x squared plus 5x squared, the exponents just sit there. The coefficients change. You get 7x squared. The exponents did nothing. They were lazy. Then when you want to multiply, you have x squared times x to the fourth. The exponents are like, oh, we don't want to multiply. That's a lot of work, but we'll add for you. Exponents do this. They actually talk to each other. You may not believe this, but they do. And then the last thing is that we just studied, if you want to raise to a power, so let's say x to the third and then square it. When I raise to a power, I multiply the exponents. The exponents are sitting there like, you know, we really don't feel like raising to a power, but we'll multiply for you. So that's one way you can try to remember what to do with exponents. Whatever operation you're trying to do on the bases, the exponents are one step behind. They're a little bit lazy.